Buenos dias! In this video, we're going to be discussing section 10.6, solve quadratic equations by the quadratic formula. This begins on page 671. So we've discussed, several different ways to solve quadratic equations, which are equations that have x squared that are to the power of 2. And we have gone through factoring and using the zero product property. We have gone through graphing and just identifying the x-intercepts off the graph. We have taken the square roots. We have completed the square. Alright, so now we're finally going to get to the quadratic formula. Quadratic formula, quadratic equation. Alright, so here it is without further ado. So, we need to recognize that first our quadratic equation has to be in standard form. That is this right here, ax squared plus bx plus c equals 0. Alright, so it should definitely be set equal to 0, and it should be there in standard form, in decreasing polynomial order. So I'm going to need the a, the b, alright, and the c. Alright, and then into my equation, I have x equals negative b, or the opposite of b. I'm always going to say the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a here. Alright, and I say the opposite of b because what if b is actually, like negative 3? Then the opposite of negative 3 would be positive 3. Alright, so there are a couple restrictions here. A cannot equal 0. The reason a can't equal 0 is, boom, it's in the denominator, so 2 times 0 would be 0, and we can't divide by 0. That's illegal. And also, b squared minus 4ac must be greater than or equal to 0. If you look at where b squared minus 4ac is, it is underneath of our square root house here. Alright, so I can take the square root of 0, but I cannot take the square root of a negative number. So it has to be greater than or equal to 0. Alright, so what are the solutions of 3x squared plus 5x equals 8? So step 1 here, we're going to have to rewrite it. But there is another way. Instead of solving the equation, you can check the answer choices in the equation. Alright, so when you check these solutions here, or what we're trying to find out if they're solutions, when you substitute in the values for x here and x here, you should get a true statement. Alright, so both of them should come out to true statements. You should get something that ends up looking like 8 equals 8. That's true. Alright, so if it's a multiple choice question, that's one way to go about it. But the direct way here, write your original equation, and then subtract 8 because we need it to be set equal to 0. And then you need to write out your quadratic formula. It's always helpful. If we were actually in class, I would be calling you all out into the hallway one by one and have you tell me verbally what it is, or I'd have you write it down. You have to memorize this. In Algebra 2, it has to be memorized. Alright? Because as you move forward in mathematics, these are things that I think you know. And, if we've covered it, I'm going to assume you know it. Alright, so the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I'd have you guys race. Alright, so you substitute in the values for a, b, and c correctly. A is positive 3, b is positive 5, and c here is negative 8. Alright, so then I get negative 5 plus or minus the square root of 121. I can actually take the square root of that. That's 11. So then I end up with negative 5 plus 11 divided by 6, and negative 5 minus 11 divided by 6. So my final two solutions, when I separate out the plus and the minus option here, I get a positive 1 and a negative 8/3. So if I go back to my problem, that is C here. So looking back, that's a positive 1, negative 8/3, that is C. Alright, so example 2, solve 2x squared minus 7 equals x. Of course you want to write out your original equation, and then get everything on the same side, set equal to 0, and making sure that you have it in the correct order from your x squared to your x to your constant. I would write out the quadratic formula, identify a, b, and c, substitute in those values, and you need to make sure you're also working according to order of operations, PEMDAS. PEMDAS, alright, where we look at our parentheses or grouping symbols and exponents first. So I need to deal with those sets of parentheses, that set right there. I can deal with that and deal with that. I can do all of those 4 groupings at one time. Alright, and then I add and subtract there. I get the square root of 57, which is not a nice equal number, so I can then break it apart. 1 plus square root of 57 divided by 4. And if you're typing this into your calculator and you're not getting that, here's what you're not doing. You're not putting that numerator in parentheses. Be very careful. You want the entire 1 plus square root of 57 divided by 4, not just the square root of 57 divided by 4. Your calculator is going to mess that up if you don't use parentheses. Alright, so our two approximate solutions here are 2.14 and negative 1.64. Alright, and then a check. Of course, if you have a graphing calculator, you'll be able to do this, but anybody can do it using desmos.com. If you type in your equation in standard form, you can see that the x-intercepts would hit approximately at those points that you found. So here's some guided practice. Why don't you practice memorizing the quadratic formula and then use it to solve these. So feel free to pause the video and then double check your solutions. Alright, here in example 3, we're going to be talking about film production. For the period between 1971 and 2001, the number y of films produced in the world can be modeled by this function. Y equals 10x squared minus 94x plus 3,900, where x is the number of years since 1971. So for example, if x was 1, it'd be 1972. If we were talking about 1975, it would be 4. In what year were 4,200 films produced? Alright, so in that case, y is going to equal 4,200. So here's my original function, and then I replace 4,200 for y, since they said y was the number of films, and we have 4,200 films. So after that, my step is going to be to move that 4,200 to the other side by subtracting. Right, they actually made a little mistake in the slide there. That should be positive still. So when they subtract 4,200 from each side, my constant ends up being negative 300, and my equation is now written in standard form. Alright, so I identify my a, b, and c, and substitute those into my quadratic formula, and then I work one step at a time. I would deal with your parentheses first, and then I would end up adding or subtracting whatever happens in there, and then I'd take the square root. Alright, and when we look at taking the square root, it doesn't come out evenly, but we do want to split the two options into the plus or minus, and we get approximately 12 when we take 94 plus the square root of 20,836 and divide that by 12, or by 20, and then we get approximately negative 3. So, the solution negative 3 can be ignored because we are talking about, a time frame here. That -3 would actually represent 1968, which is not a possible answer for what the problem laid out for us. Alright, so there were 4,200 films produced about 12 years after 1971, or your solution is actually 1983. So here's an additional guide practice for you. Find out when there were 4,750 films produced. Alright, so a summary of all of the different, possible ways to attack a quadratic equation. So if you see an x squared and you want to solve for x, you gotta look at, your different options. So, number 1, factoring. I do think factoring, especially if you see x squared and there's not an a value out in front, if that a value is 1, factoring could be a really, really easy way to go about it. Alright, graphing I think is arguably one of the most difficult because it just involves the most steps of finding your axis of symmetry, finding your vertex, getting, your y-intercepts, and then what if it's not exact, you're approximating, and you want to make sure you're hitting the right spot on the x-intercepts, or x-axis there. Finding the square roots. I think the square root is another very easy option. Alright, that is when we do not have a plain x term. Alright, so we can move the constants to the other side and then take the square root of x. Completing the square is another one that's a little bit cumbersome as far as work goes, but it gets you to a point where you can take a square root and then solve for x. And then the quadratic formula. That is a fail-safe. So it is going to work no matter what. Alright, the other ones, you might not be able to factor it. Graphing might be difficult because it might not hit at really nice points. Finding the square root, well, it could be a really ugly number. Completing the square, depending on the numbers, it could be difficult. And then quadratic formula, that is your fail-safe. I would memorize that formula forwards, backwards, get to know it, and love it, because you'll be using it in Algebra 2. So in the following examples, we're going to be looking at, which method am I going to use. So, tell what method you would use to solve the quadratic equation. Alright, right now it's not easily factorable. That a value is pretty big, and 7 is not factorable. So, they say the quadratic equation can be solved using square roots. So all I'd have to do is add that 7 to the other side, divide by 10, and then take a square root. That's going to be the easiest because it can be put into that form x squared equals d. Alright, example 4b. X squared plus 4x equals 0. What method would you use? The solution that the book comes up with is the equation can be solved by factoring. I completely agree with that. So, out of both of these terms, their greatest common monomial is x. So when you factor that out, you get x, and x plus 4 equals 0. So you factored it. From there, you use your zero product property. X must equal 0 here, and then x plus 4 would equal 0, or x equals -4. And boom. Alright, so they have their explanation. Also, the equation can be solved by completing the square, because it is in standard form, where a is 1, and b is an even number. Alright, but that's going to involve a couple more steps in my personal opinion. Alright. C, 5x squared plus 9x minus 4 equals 0. The quadratic equation, because it cannot be factored easily. Well, how do you know that? Well, you try it and you fail. Alright, that's fine. Life is made up of mistakes and failures. You learn from them. Alright, and completing the square will result in many fractions. I have no problem with fractions. I like fractions, but you might not. So, you might have tried those options and didn't like them, so using the quadratic formula. It is a fail-safe method. Alright, guide practice 5 here. X squared plus x minus 6 equals 0. That one, factoring, it is going to factor very, very easily. I would always look at factoring and then see if there is a x term there to see if you can take a square root. So this one, it factors easily. What multiplies to negative 6? That adds to a positive 1. That is x plus 3 times x minus 2. And then you use your zero product property. Alright, so factoring is your best bet. X squared minus 9 equals 0. Well, that one, you can factor, of course, since this is a difference of squares. It would factor into x plus 3 times x minus 3. Or you could also take the square root. Both of them are going to be, 2 steps each. So you'd have to add 9 and then take the square root. Alright, got practice 7 here. X squared plus 6x equals 5. And completing the square, we can complete the square because the equation is written in the form ax squared plus bx equals c. A is 1, which is, optimal for completing the square here. And b is an even number. Alright, since that wasn't actually a requirement when we completed the square, but it's ideal because remember how we have that b over 2 squared that we'll be adding? If b is even, that means when I divide it by 2, it's going to work out really nicely. Alright, another method, you could get that equation into standard form by subtracting 5, and then use the quadratic formula. Alright, if you guys have any questions, feel free to hit me up via email or take advantage of those office hours. I'd be more than happy to chat with you guys and clear up any confusion. I look forward to hearing from you. Good luck.